All right, so this lesson is on simplifying rational expressions, and we're going to go ahead and talk about that. But before we do that, we have a special guest that would like to say hello.
Hi kids, cherish learning.
Your job is to guess who that was. We'll talk about that tomorrow in class. Thanks, Mr. Buxton. All right, so for this first example, 2x squared over 4x cubed, you'll notice that this is real similar to stuff we've done before. We're just reducing. The idea of why I'm showing you this is so that when you see later on when we start factoring, you'll kind of see how it applies to the same principles here. When you're working with this type of problem, we're just looking to reduce, getting rid of the 2's for both of them, getting rid of the x squared and the x cubed, and so we end up with just 1 over 2x as our final answer. All right, so for example 2 here, we have x squared minus 9 over x plus 3. The idea behind simplifying rational expressions is to factor and then try and cancel out like terms. For the top here, we can factor using dots into x plus 3 and x minus 3, and that's all over x plus 3. And then because I have a common binomial in both, I can simplify this to just x minus 3 as my final answer. The one thing that we can't forget to do here, and I know you've seen this before, is to put down restrictions. All right, restrictions come in as to what the denominator could not be equal to. It's not extremely important here with simplifying rational expressions, but it's extremely important when we start working with rational expressions and we're solving, and so now it's set equal to 0. You have to make sure that you can't make this denominator 0, because otherwise the entire problem is undefined and you can't find a value for x. So we're going to kind of get in the habit of doing that now by taking whatever the denominator is, setting it equal to 0, and then solving and saying, okay, x cannot be negative 3. So we get our final answer that looks something like this. X minus 3 after we've reduced it, where x cannot be equal to negative 3. Because if it was negative 3, then the whole problem would be undefined. Please don't forget to find restrictions for all of these problems. All right, so take a look at example 3 here. X cubed minus 5x squared plus 6, this should be 6x over x squared minus 36. We're going to factor the top, factor the bottom. Factor numerator, factor denominator. First off, pull out an x. In the denominator, we're going to go ahead and make that into x plus 6, x minus 6. Factor the numerator again. Can't even do this today. There we go. Minus 3, minus 2. All right, so we end up with these pieces right here. You'll notice that nothing cancels, and that's okay sometimes. What will happen is we'll try and simplify this by factoring it, and nothing can be reduced, and it's okay. We can leave this as our answer. In order to write that as our answer, we cannot forget to put in our restrictions. So we take both the denominator. Before we start to even cancel here, even if we could cancel, take both your pieces in your denominator, set them equal to 0, and solve. So it's this answer along with x not being able to be equal to negative 6 and positive 6. All right, look at example 4, please. Factor the top using doc, difference of cubes. Let's make sure I get this right here. Plus 2x plus 1. And then in the denominator, you end up with a 4x squared minus 4x plus 1. We can factor that into 2x minus 1 quantity squared. Before we go ahead and cancel this out, we want to make sure that we put down our restrictions that x cannot be a positive 1/2 by setting this part equal to 0. We don't have to do it twice because it's the exact same thing, so it will give us the same answer. So both times, x cannot be positive 1/2. Then once we do that, we can cancel the square and one of the binomials or the binomial up top and get a final answer of 4x squared plus 2x plus 1 over 2x minus 1, where x does not equal 1/2. All right, and the last example I have for you, we'll obviously have some more stuff on worksheet 12 that you'll be able to work through with this, is a problem that looks like this. X minus 5 quantity squared multiplied by 5 minus x quantity to the negative 3. All right, so the idea here is that we first want to set this up as a rational expression with a fraction. And so what we do is we take this negative exponent, we push everything to the denominator, and this becomes x minus 5 squared up top and 5 minus x to the positive 3 in the denominator. Now, we want these to be identical, and right now they're similar, but they're not identical, so we need to rearrange the terms here and turn this into x minus 5 quantity cubed, but by doing so, we have to put a negative out front. We're pulling out the negative to be able to do that. All right, let's scoot this over just a little bit, and you can see that that's what we should get. Now we've got 2 of them up top, we've got 3 in the denominator, and so we end up with 1 over x minus 5. All right, now again, once we have this as part of our answer, we need to write down what our restrictions can have to be, so x cannot be a positive 5 in the denominator. And then there's our final answer. Now again, this is just a preview, kind of a simple introduction to simplifying rational expressions. My hope is that this will help you as you go through your worksheet on worksheet 12 on simplifying rational expressions. And we will pick this up on Friday and review this a little bit more, and we'll talk about how we're going to continue with the idea of factoring and rational expressions and how they're going to be combined together at the same time. So that concludes simplifying rational expressions.